Hello, everyone. Welcome to this talk. I'm going to talk about how we build Shazam for Android. I'm just going to walk you over some of the practices and how they have evolved over time, lessons we've learned. And I wanted also to give this talk to talk about Android code quality, which, given the spread of Android applications out in the world, there's not enough of that content. Specifically, I'd like to also cover quite a lot about testing strategies for Android, which seems to be, as we will see in a second, kind of the Wild West of testing. If you're not an Android developer, don't worry. There are still key takeaways for other platforms and systems. And of course, I'd like to introduce myself. My name is Iordanis Giannakakis. I'm the team lead of the Android team at Shazam. This is my Twitter handle if you want to send some questions now. There's going to be enough time for questions in the end. There's a microphone there if you guys want to speak directly there. So every time I introduce myself, people ask me, how does Shazam work? It's a good question. Basically, it works for every device that has a microphone. It existed for the last 12 years, this service. Initially, it was a text service, so you would dial a number, let the microphone hear the music for 10, 20 seconds, and then you would get a text back with a result. Of course, over time, things have evolved. There have been, the evolution of smartphones, where Shazam really took off. We now have, obviously, clients for Android, iOS. Recently, we've added a Shazam for Mac. If you haven't tried it, do. It's pretty cool. We have clients for Google Glass, some more experimental stuff. The way it works is every device with a microphone records a segment of audio that it creates an audio fingerprint of, then sends that back to the server, and then the server does the search over like 30 million tracks or something crazy like that, using really powerful custom hardware, using GPUs, NVIDIA GPUs. So some numbers, some scary numbers, just to give you an idea of the volume that we are facing currently. We currently have 100 million active users, monthly active users, across all platforms. This is not just Android. And 15 billion total Shazam since the service started. So that's the world's population doing a Shazam twice. So that's pretty scary. If you haven't used Shazam for a while, you may think that this is, a utility app that sits on the app drawer. You use it whenever you want to find a song, but over time, we want to make users more happy. We keep adding features. So currently, we offer a personalized news feed. So if you're interested in an artist and if you have shown interest for a track in the past, we offer you news based on those artists. We're adding, of course, more social features on the app and more deeper integration with second screen. So if you have noticed some of the announcements recently, if you're in cinemas in the States, you will be able to Shazam the pre-show. So that's pretty cool. Of course, when you keep adding these features, the complexity of your app starts getting bigger and bigger. There has to be a way for, if you're an application developer, to verify existing behavior. When you're dealing with such volume, it's pretty imperative that you have to do that. Of course, the only way to achieve that is automated testing. Any application that over time gets sufficiently large doesn't scale unless you have some sort of automated testing. The problem with Android, though, is that it's a container, it's a framework, it's a big framework, and there were no clear strategies about how to write unit tests or any tests, really, apart from connected tests, so tests that actually deploy on devices. So it's pretty much of a wild west of testing. Different people use different approaches. We started using a while back Roboelectric, which is trying to emulate Android on the JVM with mixed results. And it's definitely not as mature as the Java world. So, of course, it's going to be a lot harder. The toolsets, though, have been improving over time. Recently, we have, when I say recently, about a year ago, greatly added support for connected tests. So there definitely is some improvement in that, but there's still no one single way to do things. Some of the things we've achieved with testing over time include faster releases. In the past, this was about once every 2 months. Recently, we've managed to make that a lot shorter, so we are now shipping a new version every 4 weeks, probably 3 weeks if possible. We're just trying to find the right balance between what's not annoying for users. So whenever you push binaries too often and end up on people's devices, we get the occasional reviews that why are you updating so often? So we try to find the right balance there. The best thing about shipping often is that usually it's uneventful because we create let's patch releases. For the functionality we ship with each version is a lot smaller, and it's very well tested. Faster releases also allow us to do a lot faster business decisions. So for a small company like Shazam, when we want to move fast, that's the way to go. Some other things we've achieved with testing, of course, and especially when we are designing our code to be test-driven, is the code quality we'll achieve. This is a screenshot from SonarQube. Unfortunately, I haven't been able to update this graph because the Gradle plugin for Android, the Sonar Runner, doesn't work with the latest SonarQube version, but this is like 6 months old, but it's still improving. The good thing with testing is that we've managed to change key aspects of the app. So if you try the app today and you compared it to a year ago, pretty much everything underneath, including network layer, local database layer, tagging engine, everything is different. But of course, you don't notice the difference because everything behaves the same. And of course, testing gives you that confidence. So I describe testing as something magical, of course. So why don't more people do it in mobile? Why do people still prefer doing manual QA? I think the answer for that is the initial cost. This is a graph from TestDroid, but I think it correlates massively to my experience. Whenever you have to start to introduce testing in your app, that's going to be an initial cost about how to do testing, and of course you need to write probably frameworks and cover some of the lack of tool sets. Over time, as you can see, the more features you add, you try to manage the costs, keep them quite low, and you can see that the slopes between the manual QA and automated testing, of course, is very different. This has a very powerful benefit of, for smaller teams, there's less need for investing in manual QA, or manual QA can be taken away from tedious tasks, verifying very simple things, which may get boring and mundane over time. And instead, the QA team focuses on actually breaking the app, doing exploratory testing. So that's pretty powerful. People don't write tests because they think they're hard, and that's where we started as well. Easy tests should be really easy to run, very fast to run, produce good diagnostics, and they have to be readable. There are no clear indications of how to do that on Android, and of course, with this talk, we're trying to cover some of that. The other benefit of tests being easy is actually developers will write them and run them before each commit. That makes your build stable, and over time, it gives you speed. So imagine this case where a product manager, owner, walks up to me and says, I want this new feature. I want a check-in service for Shazam. So imagine you're near a bar, you make a discovery, and I want you to check that discovery in that venue. That's an imaginary feature, by the way. It doesn't exist. It may exist sometime in the future, but I'm not sure. So this sounds like a very easy feature, of course. It's just a check-in service. You can get the location from some other web service, probably. Later on, this feature may expand to creating charts, let's say, for a music venue. And as you can imagine, it can get more complicated over time. So how would we go about doing something like that? I'm going to talk about it doing test-driven methodologies. It doesn't necessarily apply to all teams, but it definitely applies to ours. Unit testing, TDD and BDD have been around for at least 15 years. They're just a very simple explanation. Red-green refactor cycle, TDD, that started about 10 years ago with Ken Beck. The idea is that the important part for both of these cycles is the DD. So you have a system that drives you when you write code, with the added benefits of better design and predictability. The complexity of these two cycles is completely different, of course. The TDD cycle, it applies to classes or clusters of classes or methods. So it's very local. You would run these tests probably tens of times per day, if not hundreds. And they are quite technical. Of course, they have to be readable as well. The BDD cycle applies to tests given in a completely different format. It applies to behavior, so probably full features. And of course, you run those probably once a day or whenever you manage to finish a feature. So why do we do things test first? As I said earlier, it doesn't necessarily have to fit with every team, but it definitely works better for us. The reason why we do it this way is because it makes code easier to write. If you write code first, then you have to write the tests, and then probably have to go back to your code and retrofit it to make it work with tests, which is a bit odd. It's definitely a lot easier to start with the tests and let the tests drive the design. Another thing we have found over time is that it eliminates external dependencies, and external in this case, I mean external to the Android team at Shazam. So, of course, we're application developers. Most of the stuff that we do at some point will have to hit the server, but the server feature may not always be ready. So it's very beneficial for us to have agreed an interface with the server, and then in our tests, we can start building the feature by producing canned responses, hard code responses. Another external dependency in this case are designs. You don't necessarily want to have to depend on pixel perfect designs for the QA team to do the QA. But as long as you have agreed the behavior with a product owner, you can very easily put the behavior there, have the tests for the behavior there, and then fine-tune the designs. And of course, it's a lot easier once you find an issue to reproduce that issue, run the test many times, and let everyone know why something works or doesn't work. So this presentation will also be test-driven. So we're going to start with the outside layer, defining how we write behavior tests. I like to think of tests as small experiments because that's exactly what they are. They have to do with setting up an environment, then a trigger happens, and then you notice what happened, the results that happened. Cognitively, we are very close to that. We use that methodology, without understanding that many times a day. That makes tests written in that format also quite highly readable. Usually you have a step where you actually arrange the environment where everything will happen. Then there is a trigger, something that acts and produces an action. And then you just make the assertions that we're all aware of from our testing experience. So let's see how that applies to the example I said earlier. If I ask you to read this, you'd probably be able to understand exactly what's being under test here. And this is something that you can sign off with a product owner, and the QA team can also read this and understand what's expected from this feature. So you're near a music venue, and when the server returns a result, when the user presses the button, they can be prompted to check in their discovery. So the way we have structured this in real code is very simply like this. So Gwen is a library that we wrote internally. It's syntactic sugar for that enforces you to write tests in this way with a given when-then format. It's not specific to Android, so after we started this library with Android, the server team also started using it in other teams. And it takes away the necessity to have feature files and that abstraction between frameworks like JBehave, Cucumber, or you name it. None of the code in the Gwen library does anything. It's just syntactic sugar. The real actions are in the actors. In this case, the actors is the user and the server. So if you cracked open that method, those methods is near returns, Shazams, and can check in. This is where the real code lives. But when you read this test, you don't necessarily need to know the implementation of what's happening underneath the hood. You just don't care about it. You just want the test to be readable. Interestingly enough, using some methodologies like dependency injection, we can run exactly the same tests for both our phones and tablets, just because we inject different actions to happen when you have tablets or or phones. Over time, importantly, you have written enough of these, so in general, you will have a dictionary of steps that you can then reuse for the rest of your tests. So if you think about the server returning a known result or the server Shazamming, of course, these are very common, and already we have 50% of the steps to reuse in other tests. So that's pretty powerful. So other Android tools that exist out there that have helped us over time are Espresso, which is a library that lets you run instrumentation tests, so connected tests, pretty fast. It's very recent. It's not under heavy development, but it works pretty well right now. Robotium is what we originally started with. It was more mature and has been under development for a longer time. The added cost, though, is that Robotium is a bit slower because it doesn't have hooks in the system the same way that Espresso does. So it has a lot of waiting, revalidating the view hierarchy, the views, and that over time can get quite slow. Fork is a library that we have written. We're going to have an example later. It's part of us trying to cover some of the lack of tools out there. And in this case, it was the lack of tools to run tests really fast, connected tests really fast. And the Hammock server, which is a very simple, again, syntactic sugar library written on top of the mock web server from Google. And we use Hamcrest language to just express some expectations for the server and then return some results. The important thing to note is because we are, everything that happens in those steps that we discussed earlier, the test doesn't have to change when we have been migrating from Robotium to Espresso. So early on, I talked about the two cycles, the TDD and the BDD, and this diagram adds a secret to blue arrows. And I'm going to explain exactly what these are right now. It's something that we can't test or we don't want to test because it's very complicated. So what is that? On the right, I'm not expecting you to be able to read this diagram, but it's a very complicated diagram that explains the interaction of the life cycle between activities and fragments. Any Android UI, any screen that will appear on the screen, any UI that will appear on the screen will be based on either activities or fragments, for those of you who are not familiar. What this is effectively the container of your UI. And of course, because this diagram is extremely complicated, it takes people months. It took me definitely months to be able to master this diagram. All this complexity is compounding your need to write tests for your logic. So ideally, what you want to do is not having to test the container itself. You want to test the underlying code, your code. You don't want to test the framework. Another simple example is the broadcast receivers, which is another mechanism that Android provides to read messages that have been broadcasted to the device. Instead of just trying to intercept that using some other libraries like Roboelectric, instead you create a delegate, very simple delegate for broadcast receivers, and then that delegate is code that you own and you can test as you would like. Earlier on, at the keynote, we saw some fancy, nice animations that material design provides. Of course, all of these animations, transitions are definitely not easy to unit test, and even if you try to do it, you would spend a lot of the time with very little benefit. Our approach for testing those things are just manual testing. They do require human interaction, people to play with it and see if everything is running smoothly. In case we find visually that we need to do some optimization, we just go back and use the tools to understand what's happening and fix the animations themselves. So I'm going to state the obvious, and what we do test is anywhere where we have logic. So presentation logic is the first thing. We want to test when devices show things in and out of your screen. There is definitely logic connected to that, so we want to unit test that as closely as possible. And of course, the business logic, which, if you forget, if you put Android aside for a second, and if you were just writing the app from scratch or for a different platform, these are the business rules. These lend themselves very well to actually writing unit tests for them. Again, the whole point here is to separate the framework from your logic, and that's not always easy. So I'm just going to go ahead and show you how we have tried to do that. If you have used any visual frameworks, of course, it's really obvious that the MVP pattern lends itself very well for this. The whole point of the MVP pattern is that you separate your model, your domain model, to the rest of Android. So if you took model apart, this can be a pure Java jar that then is just a dependency for your application. It's platform agnostic, and theoretically, you can just create a new app with the same rules. View is Android specific. It depends on the system. It depends on Android being there, because it contains all the interactions, event handling, screens, and all the visual elements. I mentioned earlier like broadcast receivers. That theoretically could be a view, although the name is a misnomer in this case. Then we have the presenter, which orchestrates the two. So it gets events from, of course, the view. It does some presentation logic, calls the model, applies the business rules, and then reports the results back to the view. So how that translates to Android, it's exactly the same, but Android, of course, has some lifecycle callbacks for your screens, let's say. So it tells you when the screen has started or stopped. Those are the green and red arrows in this case. And of course, the view has to delegate those calls back to the presenter, and then the presenter can start the presentation. There are different callbacks to the system. There is the on start and on resume, if I've ever done any Android development. What should be a beginning to your presentation, it really is up to your application. So just to sum up, what this has given us is it has allowed us to make the presentation logic testable, which otherwise wouldn't be. We would have to use Roboelectric, as I mentioned earlier, which allows you to emulate Android on JVM, and sometimes this can get a pain. That's why we have avoided everything as much as we can from Android dependencies. We also don't need to test a view, because views in this case are very simple. They are usually, there's no branching in them, because the presenter has taken care of calling the right things. And of course, we have a higher level UI tests to test view-related things, things on screen. I'm just going to go very quickly through dependency injection, because I'm sure that you must be aware of it. First of all, I'd like to say that it's not a framework, because whenever people discuss about dependency injection, they mention Spring or Dagger or anything like that. It's a software pattern. What it is, it allows you to break hardcode dependencies. That you may want to do that for two reasons. First of all, you may want your runtime to be more flexible and decide an implementation based on the runtime, based on runtime characteristics. And of course, testing would not be possible without dependency injection. What is important is to specify behavior and features that your code will have, not how they're implemented. And in our case, we don't use any frameworks that exist out there for Android, just because we find it a lot simpler to not use any. A very simple example of how that would look like in real life, we have the same feature, feature X, which might have a red or purple implementation. Let's say that this is loading a track, and this can be loaded from either the network or the database. The client, all the client cares about is loading a track. It doesn't care about how that happens. And of course, doing that would require a third component, in this case the injector, to decide based on the runtime what implementation it should pass to the client that needs this feature. As a side effect, and because we have made that, we have that flexibility at the runtime, is that you can change the feature X at test time, so you can very easily write unit tests for it. So I'm just going to show you some code of how we have achieved that in our code base. First of all, I'm just going to start with a model. Very simply, I'm just going to show you a class that knows how to, an interface and a couple of classes that know how to load venues. That's all we care about at the model level. This is completely platform agnostic. It doesn't have to know anything about Android. You may load something from the network, which can be slow. You may have a database lookup, or later on you may have an implementation that tries to orchestrate the two. So as far as the client is concerned, it doesn't need to know. It just has a venue retriever instance. And just to highlight that, if you notice the first line, the venue retriever there returns the interface. Of course, it doesn't need to know what implementation it got back. And it would do dependency injection in this case statically, because we don't need to unit test the activity, because as we said earlier, this is part of the platform and there's no need to do it. A couple of things to note here is also that now the activity is implementing the result view interface. This interface for now is just brand new. It came out of nowhere, so it's going to be empty. Another thing to note is that when Android creates screens, of course, it calls the onCreate callback. That's what we intercept to create the presenter, which is going to be the class that will be responsible for putting everything on screen. So we pass the result that we somehow loaded, and the venue retriever has been injected to this class. Then we just gonna intercept the onStart method, where we tell the presenter to start presenting. So this is going to be the first component of the application that's actually test-driven. Until now, nothing was orchestrating what was happening between the view and the model. But now we have something that's, again, purely Java. It doesn't have to know anything about Android, and can just do this thing for us. So we're just going to start TDDing the very simple method of start presenting. Of course, initially we show the result. Then we use the venue retriever to retrieve a venue. And when that happens, we show the prompt for users to check in. This lends itself, as I said earlier, very nicely to be unit tested with traditional methods, JUnit4, Mockito, or JMock, or whatever it is. As we noticed in the previous slide, we now have the result view. The result view now has two methods, the show result and the check-in prompt. This came out of nowhere, of course, because we needed them. By doing this, of course, we have to go back to the activity and implement those methods. And now these are really easy to see how they would be implemented. All you need to do is just bind the results, the data that the presenter loaded from the model, and show them back to the view. Usually the complexity for these methods would be, the cyclomatic complexity would be 1. There would be nothing there to test. So that's exactly what we do, that we don't unit test activities. if you want to make sure that everything is wired in properly and everything shows up on screen, of course you will write higher level UI tests, and that's exactly what we do. As I said, we've separated completely from the Android testing framework, so all we use is JUnit 4. We try to avoid Robolectric as much as possible, but still we have to use it because whenever you hit an intent or some other Android dependency, you will get the runtime exception, the famous runtime exception. And we use traditional things like Hamcrest and JMOC to write our unit tests for what I just showed. So we talked about how to make acceptance tests and unit tests readable. That's hopefully something that has been demonstrated. But when we are talking about connected Android checks, so connected devices, so far there have been some challenges with it. So diagnostics are not always visible to the people who run them, to developers. So it's hard to tell sometimes what's broken. And of course, they're really slow. So how have we done it? Of course, when we're talking about acceptance tests and unit test speed, we all use some form of continuous integration. We use Jenkins, and of course that's necessary for any sort of instant feedback. The recent Android support for Gradle support for Android has helped a lot. Until now, we had to use something like Ant or Maven. But now Gradle is actually making that a breeze because it integrates nicely with your IDE. You create a project, and exactly the same build scripts will run on the continuous integration server, and that's great. Internally, we use internal distribution tools, so anyone in the company can subscribe to those and get immediately at least a preview of what the next version will look like. So we try to eat our own dog food. We try to force people to test the app as much as possible. I briefly mentioned earlier that connecting tests are really slow. Gradle has helped the issue with consistency between IDEs and continuous integration servers, but again, it's still pretty slow. The reason for that is when you build an Android app, of course, you have to do the dexing, so transforming the bytecode between Java classes and dex. Then if your app is big enough, you have to run ProGuard, which is going to strip everything that's not used. And all of that, of course, plus the installation to the device takes time. If you just want to do a simple run of running your tests, installing and running the tests, that's going to take at least in the order of minutes. So that's not ideal. The problem with execution, our approach has been, so far, naive scheduling. So no matter what tool you use, if you use Maven in the past or Gradle to build Android apps and run the tests, the problem was that the system takes the test suite, installs the test suite on all the devices, and then runs all of the tests on all of the devices. And sometimes, if you can imagine, that can be wasteful. So we started with a system called Spoon, provided by the talented team at Square. What it does is allows parallel execution of tests on devices. It suffers from the same problem, the naive scheduling, so it will run all of the tests on all of the devices, but on top of that, it gives some really nice reports. So we identified something that was missing. What we then, our approach for doing this was that we don't have to run all of the tests on all the connected devices because that's, as I said earlier, it seems to be quite wasteful, especially if you have a list of very similar devices or very similar emulators. Running one test at a device is enough most of the time. So we created this notion of pools. A pool represents a set of devices with similar characteristics. Similar enough that you just need to run one of the tests in this pool, not in each device. So we improved the scheduling by quite a lot. We now split, in this example, if we have a test suite of 3 tests, test suite of 3 tests, we run only one of them per device. So that gives quite a lot of parallelization, and you can, of course, when you're adding a lot more phones or emulators to your build system, it makes test execution a lot faster. Just to give a very brief demo, pre-recorded demo, you can see that we've fired up 5 emulators. We are going to execute tests for only one package, but then you will see that every emulator will run different tests, not the same. Of course, this has 5 emulators. That's going to run 30 tests in a minute. If I added another 5, that time would be reduced. And that's, I think, is pretty cool. What it allowed us to do is to actually use CI. It was a game changer because before every developer commits to Git, they can run the tests locally before they do so. So that gives us a lot more confidence about tests not being broken and the code not being broken. Again, because it doesn't run all the tests on all the connected devices, it doesn't give full validation with every commit, but it's definitely good enough for CI. And we've noticed that very rarely you get false passes. To get that extra, confidence, we've added what we call the spoon mode. So at nightlies, and when time is not an issue, we run, of course, we create a pool for each device. So we run all of the devices, all of the tests on all of the devices. It gives very similar diagnostics to Spoon. So we provide screenshots when things get broken. And recently we have been expanding that to capture videos so that you can then go back and see what the interaction looked like when a test broke. But that's a work in progress. It's not available yet. Just to sum up, the idea of pooled execution has helped us speed up tests quite a lot. It is infinitely scalable because the more devices or emulators you spin up, it makes things faster. And with the current setup, we have managed to run at least one test per 2 seconds. And if you have ever tried to run roboelectric tests, it's very comparable. And it's pretty impressive that you can get the same scale on actual devices because it's a lot more powerful. So a problem is that tests are not always perfect. Sometimes they may be flaky, especially when you're dealing with high-level UI tests like this and when you use frameworks like Robotium and Espresso. And on the other hand, devices are not always stable. They might run out of battery sometimes, or some connectivity may be lost for some reason. So we try to enhance fork to keep a history of the test executions. Rows, in this case, are test methods, and columns are devices. So if you can imagine that in this case, that red column there indicates that a device has been broken. If you were to notice a horizontal red line, it means that a test is usually flaky, and you probably need to go back and check that actually what you're doing is correct. As I mentioned earlier, sometimes devices lose connectivity, or in some way, shape or form, they break. So what we wrote is another very small tool called ADB Remote that allows you to just have a web interface into devices. So we have a build room somewhere that we don't necessarily have to access, but we just connect to devices, and we can then trigger commands. If something is heavily broken, we can probably just restart the device, just shut it down. As you can see, this, actually, you may not be able to understand it from this screenshot, but it's interactive. So if I was to use the web page, I could just click on the unlock screen, and I could actually interact with the phone just by using ADB commands and events. That's also open sourced. As you can see at the bottom from my colleague. And of course, fork is also open sourced for the last probably 2 weeks, and you can get it from this link. So of course, not everything can be automated, as we have seen. Automated tests are really good at verifying behavior that we know has existed, but of course it's kind of irrelevant when you're trying to do exploratory testing and find problems, discover new bugs. Our approach is, again, that we have a very good QA team. Hopefully we're trying to get as much of the mundane checking away from them and allow them to do true QA, exploratory testing, play around with the app and try to break it. Unfortunately, they're quite good with this, so they break the app quite often and then we have to go back and fix it. Of course, they can also experiment with more devices than a CI box can handle, and different configurations for different countries and all that. When we do actually ship, we try to pay close attention to performance analytics. That's both on clients and on the server. We ship something and then we monitor stats to see what actually has happened since we did that. Every so often you may get probably some performance problems that you couldn't test against but exists out in the wild. Using, of course, something like this can help you identify issues that you wouldn't be able to meet otherwise. Of course, everyone who writes mobile apps uses some form of crash reporting. We use Hockey App for that. Of course, it means that things have gone really bad in this case. But some of the changes we have done recently, we have done them just to make sure that whenever a crash happens, we can trace that all the way back to the server, so being able to trace requests. And of course, that gives you the flexibility, the power to see exactly what happened when a crash happened and what went wrong with the server, or if the server returned a response that wasn't expected. So just to sum up, when we started doing testing on Android, we thought it was hard, and over time it has got a little bit easier, exactly because of how much we've been practicing it. We are at a point where we can actually be confident with our testing framework. And of course, this wouldn't happen if we hadn't tried so hard. We're trying to cover some of the tool set, as we have seen today, that was not there before we started. But in general, the tool set is getting better. So that's me, my Twitter handle if you want to send any questions. Does anyone have any questions now? Yeah? Yeah. The question is whether we use any particular frameworks for MVP. There have been some, as far as I'm aware, some frameworks from Square called Flow and Mortar. We usually are not so keen to use libraries that we don't control. And in this case, again, the same as the dependency injection discussion, it wouldn't offer us too much more flexibility than having a library. So the answer is no. We just use our own code, and exactly the same example as you saw earlier. It's nothing special. Any questions? Yeah. Of course, good question. Because I didn't. The question is whether how do we identify performance issues with applications? This is a good question because we don't use any automated way to do that. As I showed in a couple of slides before this one, we try to keep good track of performance characteristics out in the world. And when we identify something like a database slowness or something like that, we scrutinize the code, we run profilers, we use the Android tools just to find systrace, traceview, and all of these tools. So nothing crazy. Yeah.
results of a time series produced by the performance test and detect by statistical operations if the software is going well or wrong, because sometimes it's not only one changement, but multiple changements that impact performance.
The question is, if we long-term we can create performance tests. The answer is yes, but it's something that probably I have to cover in a talk next year, because we haven't done that. I think it requires quite a lot of effort, which we just haven't had the resources to cover. But it's definitely something we're definitely interested in. Performance is key for a time-critical application like Shazam. Any questions? Cool. Thank you very much.